So this is what I will highlight is the standard form of a quadratic function. You take it and write it in that form. You got some number a times x minus h squared plus some number k.
Yeah.
And h and k represent the vertex as pictured here. The vertex, what words would you use to describe the vertex? If I was a brother from another planet and I showed up not knowing anything about math and I see this word vertex, I say, Travontae, what is a vertex?
This I say it's the middle, like the in between of the what's ain't it's in between the intercept, the x, the thing, the
Okay,
thing
no,
in
I'm,
between
I'm, I'm working
x
with you.
intercept.
I'm working
It's
with you.
like
So
it's the middle.
yeah. So I heard you say it's the middle. So what now I'll say as a math teacher is they call that middle the axis of symmetry.
Okay.
That's like an imaginary line, an imaginary vertical line that allows one side of the graph to mirror or look just like the other side of the graph. Does that work for you?
Yes.
All right. Now, talk to me still like I'm a brother from another planet. What are the x intercepts in
The
words? In words, now, what are they?
the one I mean the where it touches the x axis,
All right. Now,
but
what can you tell me about the value of y at a point that's on the x-axis?
the value of y is zero.
Yes, sir. Yes, sir. Definitely. Definitely. So what's unique about a quadratic function is there are two values of a quadratic function that make the function equal to 0. Now that might not seem like it means a whole lot, but I could show you examples from the world of defense, like military defense and sports, where it's very important to know when a function, because functions describe things that really do happen, right? Like if I took a football and I threw it, it's going to travel a path, right? And that path is going to kind of look like a parabola, which is what we're looking at here, but it's going to look like an upside down parabola. Now, can you see that?
The football.
Yeah, if I take a football and I throw it
Oh,
as far as I can, the path that that football travels is going to look like an upside down parabola. We're looking at a parabola now. It's going to look like an upside down parabola.
yeah.
I want you to see that now. See that in your imagination and tell me whether you see it.
What on here or like when I see in real
No, I'm
life?
saying look in your imagination.
Okay.
Look at me throwing a football and watch that football travel. It's
Yeah.
going to go up and it's going to
It's
come
gonna go
back down,
down.
right?
Yeah.
Now, if it doesn't
It's like
come back down, then I really am a brother from another planet with some super strength. But if I throw that ball, it's going to go up and then it's going to come
it's
down.
gonna go down.
And that depending on what kind of quarterback I am, it might go way up or it might not go that far up at all. But I guarantee you it's going to come back down, right?
Yeah.
All right. Now I try to use examples like that to help you see that even though you might dive into this stuff in ingenuity and in all your other math classes way more than you care to, right? It really does have some physical significance. Like you're studying something that's real that can be applied, even if it's not directly applied in your class right now. It's definitely applied in many
Real life.
arenas of life. Yeah. Now, if I was going to come up with a real world example in football, if I'm having trouble deciding who I want to choose as my quarterback, man, I might actually just let them all go and throw some passes for me. And then I might take my little tablet and record on video everybody's passes, and I would put my camera on the football itself so I could see what kind of path everybody's football passes might travel. That might give me a pretty good idea of which one of my quarterbacks has the most arm talent. Nick, you ever heard that term, arm talent?
Yeah, yeah, like arm strength.
Well, arm talent now is a little bit more than arm strength. Cause see,
I mean, like
arm strength is you can really,
how
really,
far?
really throw it, but now arm talent says you can throw it and you can put it where you need to put it. Because who's your team? Who do you like?
I like I like the Saints.
All
I'm
right,
going on chips for the barbecue.
All right. Hmm. And, oh, should I say it
yeah.
before I got interrupted?
Oh, you told me you like the Saints. Now,
Yeah,
uh,
I like the Saints.
the Saints don't have Willie Snead anymore, do they?
I think no, he in Baltimore.
Yeah, he's gone. He's gone. All right, but they still have Alvin Kamara, and he catches a lot of balls, and they got Michael Thomas,
Yeah,
and they got Taysom Hill. Taysom Hill is a tight end, but he's a quarterback. Well, he's kind of everything. Either way,
he a gadget. He a gadget.
yeah. So I want two receivers I can use in my example. So let me use Michael Thomas, Alvin Kamara. Now both
No,
of
they
them.
got you can use Emmanuel Sanders. You got him.
Oh, they got Emmanuel Sanders.
Yeah,
Okay, all right. But let's use Emmanuel Sanders and Michael Thomas. Now, who's taller out of those two guys?
Michael Thomas.
All right. Now, who's faster?
I'll say. Hey, I don't know. I'll say Emmanuel Sanders.
Okay.
No,
All right.
no. Yeah, like he passes prime though. I don't know. I don't know.
But I know he's older now. I know he's a little older. All right. So now you a football man now. Do you know routes?
Yes,
All right. What's Michael Thomas's best route?
the slant.
All right. What's Emmanuel Sanders' best route?
I'll say short passes too.
All right. So
Because the Saints like to those short passes a
yeah,
lot.
they do. They do. They do. Look, they got the best short passer I've ever seen, man. And I've seen a lot of them, though. But yeah, Drew Brees is a master short passer. Actually, he's an accurate passer. Period. Now he might not have the most arm strength, but he got plenty arm talent, man. Because he puts the ball where the ball needs to be, and he puts it where his receivers like it. So
Yeah.
if Michael Thomas is running a slant, where do you think Michael Thomas wants that ball?
I'll say he wanted like it to slightly in front of him.
Slightly in front, where I don't have to stretch out and meet a defensive back the wrong way. If you see what I'm saying.
He wants to when he open. Oh, that's you.
Say it again. Now?
He wants to when he open.
Yeah, yeah, yeah. But you also, he's running an inside route, so he probably wants his quarterback to put that ball on his hands where he doesn't have to stretch or break stride. Because I wanna catch a slant while I'm at top speed, so I can break a tackle and make a house call. That's what I want to do. Now I remember Emmanuel Sanders. Now, how old are you, man?
Holding me or holding him.
Yeah, how old are you?
17.
All right. Now, do you remember when Emmanuel Sanders caught the winning touchdown in the Super Bowl? This was a long time ago, man. This
Oh,
was
you talking about for the Broncos?
no, he caught it for the Steelers.
Oh, I didn't know he played for them.
Yeah, that was his first team, man.
Oh, no, I didn't see that.
First team. And you know what? I'm probably I'm getting him mixed up. Santonio Holmes was the one who caught the winning touchdown in the Super Bowl, but Emmanuel Sanders was on his team and was in that Super Bowl because Pittsburgh has always had a bunch of great wide receivers and they don't keep them long. Like they use them and they let them go.
Yeah,
And so they let Sanders go, they let Holmes go, and both of them were kind of in the mold of Antonio Brown before they got Antonio Brown.
yeah.
But when When I saw Antonio Brown coming to the league, man, I was like, man, I hope he don't wear out his welcome because Pittsburgh will let you go, man. They will let you go. They done let two guys go, man, that remind me of you, Antonio Brown. So if they let those guys go, they'll let you go too. And they sure let them go. But anyway, I'm way off track now. I'm just trying to relate to passes and how the ball travels in a parabola in football all the time, and how even the best quarterbacks like Drew Brees, if Drew Brees and Pat Mahomes are having a throwing contest, I bet Pat Mahomes' ball is going to look a lot more like a horizontal line than Drew Brees. Drew Brees' passes will probably look like lollipops compared to Pat Mahomes. No disrespect now, because Drew Brees can put it where it needs to be put. But Pat Mahomes probably got a stronger arm, is all I'm saying. He probably does. So anyway, let's get back to the math, man. So this example that I'm showing you here, when you understand the quadratic function's standard form and can rewrite a quadratic function in that standard form, then you'll know where the vertex is. That's an important point. That's the point that provides the axis of symmetry. And you'll also be able to know where the x-intercepts are. That's an important point because that's where the function equals 0. That makes sense?
Yes.
All right. So make sure that's in your notes. Now that's something key for what you're doing now, so you can get through the instruction for this exercise. Because what I want you to start positioning yourself to do, man, is I need you to get something graded every day. You and I have had this talk before, right?
Yeah.
Travontae?
Yes.
You ever had that talk with me where I said make your goal one graded assignment every day? You got to be doing a quiz every day to keep yourself on pace to finish and finish in a decent amount of time.
Yeah.
All right.
Yeah, I ain't forget that. I know that. So I always try to at least do two or one quizzes a day for
All right.
each class.
Yep. Yeah, just keep yourself on one quiz a day, and if you can go faster than that, then go faster and do 2 quizzes a day. But that'll help you finish in a decent amount of time.
I said I know like at least gotta finish at least one quiz for each class every day.
Yeah. All right. Now, what we went over now, do you feel good about it? Now, you want me to go over it a little bit more?
You go over a little bit more. Talk get a I understand. I just need a little bit better understanding.
All right. So now, did you write down what I gave you? Because I wanna switch my screen to back to
Oh
Edgenuity.
yes. Yes. Yes.
All right. So let me. All right, give me a second now, because I'm gonna have to switch my screen. I just need to stop that share. Let's share it again. And let's get this feedback window. Let's tackle this, man, and then we'll wrap up for the day. All right. So this is a problem that is taken from your present assignment on frame 3. You got a quadratic function with x-intercepts of -1 and -7 that passes through the point -2, -20. They want to know the value of a in the factored form of this function. So I might need to hop back. I'm not going to share my screen now. I'll stay on the screen that you're on, but you have the standard form written in your notes, right?
Yes.
Okay, so let me switch back so I can see the standard form again. All right, so what information are they giving you? What information is Ingenuity giving you here? They're telling you what the x-intercepts are, and they're
And
giving
what they
you,
pass
say again?
and what they pass through. Like what points the point. I mean the point they pass through.
Yeah, but now, do you think that that point that they're giving you, do you think that is the vertex?
Yes, I say yes.
Okay,
Yeah.
it probably is. It probably is. So let's say it is.
Okay.
We can take that point and plug it in to the standard form of the equation. You see that now?
Yes.
All right, and tell me what the, let me look at what the point is again. -2, -20 is the vertex. So if I put that in that equation that I showed you, -2, -20. All right, then I'm going to end up with something that looks like a times x plus 2 squared minus 20.
Oh my God.
All right.
Hello. Yo. No, he's still at home, or he at school. I don't know. But if you show up at my house, I'm gonna call you though. All right. All right. He at school. He coming outside. He just at school. No, he at school. You know, like if he not let's try his house. If he not at his house, he at school. Let's try his house first though. All right though. All right. Oh wait. Yes, Mr. Brown. All right. All right.
All right, I'm still here now. I kept on working. All right, now I wanna share the screen again so I can show you something. You ready?
Yes.
All right, let's share.
No, you was sharing the screen the whole time.
I know I want to share a different screen. That's what I meant to say.
Oh.
Okay, this is the graphing calculator that I think I've showed you before at desmos.com. And the same calculator is also built in the Edgenuity. Let's see how I have graphed the standard form of a quadratic function based on my guess that that point they gave me might be the vertex.
Mm,
All right, now, do you see how I plug the numbers in?
yes.
All right, the standard form of what's in the parentheses is x minus some number h. So if h is -2, I've got x minus a -2. Now, do you agree that x minus -2 is x plus 2?
X minus.
X minus a -2 is actually x plus 2. Still there?
What, nigga? Oh, wait. Yes. Hey, come on.
All right, you still there, man?
Yes.
All right, all right. So let me say what I was saying again. Now, if the standard form of the quadratic function is x minus h, and we're told that h is -2, then if I'm plugging that h into the standard form, I'll have x minus a -2, and
Yeah.
x minus -2 is x plus 2. You see that?
Yes.
All right. And then the rest of the standard form is plus some number k. Now I'm told that k is -20, so I plug that in as -20. Now I am assuming that my a, right now, a is 1. That's my guess, because I want to graph this, and then I want to look at the other piece of information that I'm given. Now, help me remember. I'm going to peek back. The other piece of information said that the x-intercepts were -1 and -7. You remember that?
Yes.
All right. So now in my present graph, which is a bit of a guess, remember that now, I have x-intercepts at 2 and -6. I want them at -1 and -7. So I kind of want my graph to slide to the left a little bit. Now, I can make it slide by changing the value of A out here. Do you think I should make A bigger or smaller?
Bigger.
All right, so let's make it bigger. How much bigger now? It's 1 now. What should we make it? Just so we can see
I say
what
like
happens.
I say 2.
All right.
2 just like just
Uh,
one more.
okay, so watch that. Now it got a little skinnier, right?
Yeah. So the smaller the number, the bigger it is.
I wouldn't say that. Now let's keep checking it out. Now what should I do now? Should I make it bigger again?
Huh? I mean, yes.
All right, so I'll make it bigger again. Let's see what happens.
Well, and then
All right, so I made it 3. What happened? What did you see happen?
you got smaller.
All right. Well, I want you to pay attention to the x-intercepts. I mean the
Oh, the
yeah
X
the, yeah
intercept.
yeah. Just look at the 2 points on the
Okay.
x-axis and tell me, because what I want them to do is I want them to become -1 and -7.
Okay.
That's what I want. So should I make it bigger?
Yeah, just add one more. Just add one more.
All right.
Me. So you said -1.
Yeah, I want it to be at -1 and -7. But what I'm seeing now, you tell me if you agree, as I increase the value of A, the x-intercepts are becoming closer. They're coming closer together. See how now
Yeah, they close.
one x-intercept is about at 0 and the other one is at -4. And I
Okay.
want them at -1 and -7. So now let's look back at the answers Ingenuity is providing to us. Ingenuity is saying the answer is 1, 2, 3, or 4.
Then it said 4 is the right answer though.
Yeah, and they said 4 is the right answer.
So
All right, so where did we go wrong? Because we definitely went wrong, but where did we go wrong?
uh so like so the um so that so the X is supposed to be 4, or is it
The
like
the A the A is actually supposed to be 4. So let's go back
you know
and do what it said do. Yeah, our X is supposed to be 4.
ain't it 4 right?
Say that again now.
But ain't it 4 right now?
Yeah, it is. It is.
So
So
like
if A is supposed to be 4 now, that tells me that we might be incorrect in thinking that -2 -20 is the vertex. It may not be the vertex.
oh yes.
It just
It
it,
might just
it just
it
might
might be an intercept.
it just might be a point on the graph. That's all we know for
Oh,
sure. Now it just might be a point on the graph.
might be a point. Because it said it goes through it. Yeah, it says it goes through like through negative -2 to 20. But I would say
All right. So let's plug in x is equal to -2 and see what we end up with.
yeah, Nard. I don't know where he at. Tell me, tell me, he coming. Man, I keep on running here. Yes, I mean, Mr. Brown.
Yeah, okay. Now
Oh,
plug in x is equal to -2 in this
x
equation.
x equals to -2. How am I supposed to do? Oh, you want to write it on my paper?
Yeah, you can. Or you can do it in your head if you want to.
Oh yeah, it's in my head. It's in my head. X equals 2. Okay, I got it.
All right, so now if x is negative 2, what's negative 2 plus 2?
Negative 2 plus 2, 0.
Is 0. All right, so then 0 squared, that's 0, 2. And then 0 times 4, that's 0. So then 0 minus 20 is
Is
what?
20.
Say it again.
20? So it's 20.
No, 0 minus 20. 0 minus 20.
Negative 20.
Negative 20. There you go. So x equals minus 2 causes y to equal minus 20. So minus 2 comma minus 20 is definitely a point on this graph.
Yeah.
But it's not necessarily the vertex.
Yeah.
Not necessarily the vertex. So,
I think they just added it just to miss people. Yeah. Word.
all right, I'm gonna play with the numbers here just a little bit. See how I changed that number just now? I changed 20 to 24.
Yeah.
All right, I changed it to 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, yep, they're coming closer and closer together now. All right, well, I might be jumping down a rabbit hole here, man. I wish I could see the that part of the lesson so I could see how they explain this to you.
Yes.
Yeah, but here, let's look at the next one here. Okay, now let me share the Edgenuity screen again. You tell me whether you have done this one yet. Now, have you seen this one yet, or is that where you stopped? You hadn't reached that.
That's what I'm on right. That's what I'm on right now.
Okay. All right. So this will be the next thing you tackle, right?
Yes.
All right. You want to do it now, or you gonna do it later?
I'll just go ahead and do it now.
All right. Now, I wonder if I'll actually see what you put in. I may not.
Oh, I just like clicked on it today. I ain't get the answer. I ain't get the answer yet.
Okay.
Write the
Well,
function in standard form and use it to find the maximum height.
Turn that off.
Write the function in standard form and use it to find the maximum height.
So you want me to try to answer it right now?
yeah. I said let's do it together.
Okay. So this is the same form. This is kind of like the same format as like the last question. All it got is a graph.
Yeah, and they gave you the points on the graph.
Yeah. Okay. A ball is thrown into the air from the ground.
First, use the other point in the table to solve for the value of a. Then multiply the factors to write the equation in standard form.
Yeah, right.
x-intercepts and another point that lies on the parabola can be used to write a quadratic function.
Oh no, I'm going. I just gotta finish this stuff up with my teacher. Okay.
Okay, now, do you understand what she is saying? What the instructor is saying?
Yes.
All right. Tell me now. I'm the brother from another planet. Tell me what's going on.
This ain't like what the scenario is, or what I'm like, what we trying to do.
Yeah, tell me how you're using these points to figure out what the value of A is.
What's he trying to call her? White boy coming over here. And do not get on my phone, bro. I'll beat you up, bro. What's up? Okay, we're using the points to find what A is.
Right. So tell me how we're gonna do that now. Tell me what's gonna happen.
We gotta I'll say we gotta use 4 and 1 thing. It says on the table the factor formula. Okay.
Hey, try this for me now. You there?
Yeah.
Try the second set of values where T is equal to 1 and H is equal to 12, and plug those into the equation that
Okay.
I'll point at here. I'm pointing at it.
Okay. So I pick 1 where the T at,
Right? Put 1 where the T is.
and I pick and I pick 12 where the A at.
No, you put 12 where F of T is. F of T is just like Y. Now we're used to saying Y is equal to something times X plus something.
Yeah.
F of T is just like Y.
Okay. So I guess I pick where the other T's at. I pick 1 then.
Right. T has a fixed value. The value of T is 1. And we're trying to solve for A. We have plugged in for T. We have plugged in for F of T.
Yeah.
And we need to solve for A.
Okay. Okay. So we so we don't do nothing with 12.
Yes. But now what we do with 12 is going to get plugged in on the left side of the equation.
Oh. Okay. Okay. That is going to be. I'll put that.
All right. So we got 12 on the left side. What do we have on the right side?
We got 1. I mean, yeah, we got 1.
Well, we have 2 places where we plug in for T, right?
Yeah.
You got a T right next to the A, and then you got another T inside the parentheses.
Yeah.
So you got to plug in T is equal to 1 in both places.
Okay. That is. So I gotta solve it now.
Right? But now do you see that we're trying to solve for A?
Yeah.
All right.
Oh, wait. A, so A. So we do all that, and A is going to be. A is going to be 4.
Watch out.
No, -4.
There you go. There you go.
Okay.
All right.
And after that, it's gonna be 16.
No, hang on now. Hang on. So now you know that A is -4, right?
Yeah.
So plug that back in where I am highlighting. Now F of T is equal to -4 times T times parentheses t minus 4.
Okay.
See that? We plugged in a is now equal to negative 4.
Okay.
All right, now let's simplify that so that it will look like this expression that I'm trying to highlight.
Okay.
See how this one multiplied the t through to get t squared?
Yeah.
All right, so we're going to take negative 4t and multiply it by another t. What does that give us?
Give us 2.
Nope. You got negative 4t times t. What's t times t?
T still equals 1?
No, t is a variable now. So what's t times t?
Oh, T squared.
All right, what's negative 4t times t?
Negative 4T.
Negative 4t what?
Uh,
It's t times t.
yeah.
Negative 4t times t.
Oh, negative 4T squared.
Right, okay, so what is the term that we're going to choose out of this first box?
Negative 4.
All right, and then the next term is going to be negative 4t times negative 4. So be careful with your sign here now. Negative 4t times negative 4 gives me what?
It gives you 16.
Gives me positive 16t, right? 16t.
Yeah.
All right,
Yeah.
so which one of those answers would this one be? Yeah, it's in there.
16.
All right. Let's see, I try to be a man with it, and I don't look inside the box until I have some idea of what the answer is. But then when I look inside the box and I see the answer that I got, it makes me feel good.
Yeah.
I try not to look, though, until I have some idea of what the answer is.
Yeah.
All right. So now, after how many seconds does the ball attain its maximum height? What's the maximum height that the ball reaches?
12.
All right. And after how many seconds does the ball get to its maximum height?
2. Say
Watch
2.
out now. Watch out now.
1.
1. All right. Is 1 one of your answer choices here?
Yeah.
All right. Is 12 one of your answer choices here?
Yeah.
All right. So you probably straight with that one, I would say. Now, I'm not sure it would tell me if I'm right on my side, so you may have to choose the answers on your side and see what it tells you. But it should tell you that they are right.
Yeah, I got them right except the last 2. I said those are wrong.
Except which two now?
The last 2, like after how many seconds the ball attains the maximum height.
Okay. Well, you got it right now, right? You know what's going on now, right?
No, I ain't. That one, I got the first 2 right. Those 2 are wrong. Last 2, like 1 and 12, those 2 are wrong.
Okay. Oh, you're saying you've already done it. See, I'm thinking you hadn't done this yet.
No, like as soon as you said it, I clicked it and and then now it's wrong. I mean, like no, I know when it goes blank, you get the question right.
Uh-huh.
Yeah, like it went away. So like, I guess it's wrong. Then
You're saying 1 and 12 is wrong?
yeah, yeah, 1 and 12 is wrong. I would say it.
No.
Who? Vanessa?